Hi, in this video we're going to talk about general effective rates. We've already talked about effective rates in the context of compounding, and this is a generalization of that. I'll come back to that. At the end of the video. So we talk about effective rates between two time periods, between time k and time n, say, generally. And so at each one of these time periods I have an amount for the accumulation function. And remember that the amount of interest earned through that time period from time k to time n, we can calculate that as just the difference between the end of period amount and the beginning of period amount. I'm not putting any more money into the account. This is a per dollar of investment at time zero, or you can think of that as an investment of 1 at time zero. I also want to mention that's the same way that you would calculate, or the amount of interest and the amount of discount are the same. So in both cases, it's just the difference between the accumulation functions. Okay, so now let's look at, with effective rates, we have interest rates or discount rates. So let's start with an effective interest rate. Remember, interest is paid at the end of the period, and it's based on the principal at the beginning of the period. So I'm thinking of the principal as being the A of k value, and then the interest being paid at the end. And so the difference between the accumulation functions, on the one hand, that's the interest. On another hand, I could calculate the amount of interest by principal times rate times time. So the principal, as I just said a little while ago, is the beginning of period amount. That's the A of k. I'm introducing this I notation for the effective interest rate over this period from time k to time n. So that's the middle factor there, the I sub k comma n in brackets. And then since this is the effective interest rate over the period from time k to time n, that period is thought of as 1 unit of time. So that's why I have a times 1 there. And of course I don't need the times 1, so I could leave that off. If I ignore the stuff in the middle, then I get this equation then, and then just solve for I, divide both sides by A of k, and what you get then is a formula for the periodic effective interest rate from time k to time n. Again, this is going to be the theme throughout the video. The numerator is going to be the amount of interest that's earned over the time frame, and the denominator is the amount that you are considering to be the amount that you are considering to be the principal during that time frame. So if I turn it around and I look at effective discount rates, remember discount is paid at the beginning of the year, and I'm thinking of the principal based on principal at the end of the beginning of the period, based on principal at the end of the period. And so if I take the difference in the accumulation functions at time n and time k, that gives me the amount of discount during that time period. And again, I can think of that as a principal times rate times time, where this time the principal is the A of n value. The rate is, I'm using a D instead of an I here because it's a discount rate, but the same ideas with the notation. And then once again times 1, because the period from time k to time n is considered to be 1 unit, because this is the effective discount rate for that time period from time k to time n. So I don't need the times 1 on the end, and when I omit the stuff in the middle, I have this expression. Divide both sides by A of n, and you get this formula then for the periodic effective discount rate from time k to time n. Okay, now I want to look at kind of a special situation where the period is just from time k minus 1 to time k. I'm doing that because that's considered to be the kth period. For instance, if you had a problem and you say, well, what time units does the first period go from? Well, the first period would go from time 0 to time 1. The second period would go from time 1 to time 2. The third period, time 2 to time 3, and so forth. So the kth period ends at time k and starts at time k minus 1. So I want to go through the exact same idea that we've already gone through, but now the time period is just this k minus 1 to k. This is the kth period. The reason I want to do that is there's a simplified notation for the periodic effective interest rates in this case. It's this middle symbol here that's on this particular slide, I sub k. When the subscript is just a k by itself, like a 2, you're meaning the second period. In other words, from time 1 to time 2. And so you'll need to know that notation, though you're expected to know that notation on the exam. That's why I'm bringing it up here. So this is just a special situation. If you want to know how to calculate the this is, by the way, it's called the periodic effective interest rate for the kth period. If I want to know how to calculate that, I go through the same thought process. I look at, well, what's the amount of interest earned during that period? And that's just the difference between the A of k and the A of k minus 1 value, so that goes in the numerator. And then what am I thinking of as the principal during this time period? Well, since it's an interest rate, I'm thinking of the principal as being the beginning of period amount, the A of k minus 1. So that's where that's the denominator there is A of k minus 1. I could flip it around and talk about the effective discount rate for the kth period. Once again, I got a simplification of the notation so that what's in between the equal signs there, the d sub k, is representing the simplified notation. So if you see a d sub 4, that's the periodic effective discount rate for the fourth period. And again, same idea. Numerator, the amount of interest earned through the period. This time the denominator is A of k because I'm thinking of it's a discount rate, so the principal is the end of period amount. That's A of k. So that's in the denominator. Okay, so the summary, we have this formula for the periodic effective interest rate generally from time k to time n, and the formula for the periodic effective discount rate from time k to time n looks very similar. The only difference is in the denominator, because for an interest rate, the principal is thought of as the beginning of period amount. That would be A of k in this case. In the discount context, the principal is thought as the end of period amount. That's the A of n amount. So the denominators are different. And then I could look over the kth period. I have a periodic effective interest rate for the kth period, and then a periodic effective discount rate for the kth period. Finally, I'd like to mention compounding again. So I mentioned that this is a generalization of these effective interest rates, periodic effective interest rates that we've talked about with compounding. And it doesn't matter whether you're compounding continuously or compounding discretely. And even if you're compounding discretely, it won't matter whether you're compounding with interest or compounding with discount. All of these, anytime you're compounding, the accumulation function is an exponential. And because it's an exponential, what you'll find is that those formulas for the kth period, those last two formulas, will reduce to just constants. They don't depend on k. And so that's why when we're compounding, we talk about, say, the monthly effective discount rate. We don't talk about the monthly effective discount rate for the fourth month or the fifth month. They're all the same. It's constant. So when we're compounding, we get these constants, constant periodic effective rates, whether it's interest or discount. But a lot of times when it won't be compounding, when we're not compounding, those we have to be told what period that we're talking about. What period do you want the periodic effective interest rate? Do you want the monthly effective interest rate, say, for the fifth month or for the sixth month? It might be different. They will be different values if you're not compounding. So that's something to keep in mind. All right. Well, I'll see you in the next video.